If you are reading standard computer science textbooks right now, the architecture being taught is diverging from what is required in modern production environments. We call this model Cloud 2.0. It's focused on manual hosting, provisioning an EC2 instance, attaching an S3 bucket, and hosting a database. Scaling relies on a human engineer setting fixed rules and manually configuring a load balancer to manage traffic. Today, the infrastructure of the internet is moving away from these static configurations to handle a different class of workload. For an engineer, simply knowing how to deploy these passive, static websites is no longer enough to meet the requirements of modern technical roles. This shift is driven by the compute demands of artificial intelligence. Modern AI models require processing power that legacy hosting wasn't designed to support. Passive architectures often struggle with the unpredictable, high-intensity traffic fluctuations these AI workloads generate. This has forced the development of Cloud 3.0. This architecture is built on two specific pillars: intelligent orchestration and sovereign borders. Transitioning to this model means moving from building static networks to designing systems that are aware of their own data boundaries. The first pillar of Cloud 3.0 is active intelligence. Instead of relying on manual configuration, the infrastructure uses autonomous logic to make real-time decisions. Here, the manual load balancer is replaced by an AI orchestrator. It monitors network flow, predicting traffic spikes before they hit. The system automatically resizes containers based on real-time predictions, dynamically routing sensitive data to local servers while sending non-critical tasks to the public cloud. This level of automation removes the requirement for manual scaling scripts. Because orchestration is becoming automated, the ability to manually click through an AWS console is becoming a secondary skill. Mastering orchestration lets an engineer manage network complexity at a scale that manual intervention cannot reach. This fragmentation is not just technical, it is geopolitical. The assumption that data can be deployed globally without restriction is challenged by the national security risks of hosting AI training data on public, borderless networks. This has led to the rise of the sovereign cloud. A sovereign cloud is physically isolated and governed by local laws. In the AWS European Sovereign Cloud, external data requests cannot cross geographic boundaries. For domain-specific AI models, data residency is legally required. Sensitive information cannot leave these secured zones. These zones are operated by local residents to ensure compliance with regional security standards. This restriction means you can no longer use a single, uniform deployment script for every region. Cloud architects who overlook these residency requirements will build systems that fail to meet 2026 enterprise security standards. Meeting these security and automation requirements requires a specific set of engineering methodologies. On the 2026 Cloud Action Plan, the first method is hybrid architecture. It isolates sensitive data on a local private server to satisfy sovereignty laws, then uses a secure gateway to route non-critical compute to the public cloud for extra capacity. The second pillar is FinOps, managing the high costs of these dual-layered systems. Because GPU compute is a massive expense, AI agents identify and route lower priority tasks away from expensive high-tier GPUs, drastically dropping your cloud spend. The final step is the deployment of open-source models like Llama or Mistral. Companies are deploying these open-source models on their sovereign infrastructure to maintain control over their proprietary data. Combining hybrid architecture, FinOps, and local LLM deployment is the standard for balancing security with the economic realities of AI. This integrated model shows how Cloud 3.0 functions: an AI orchestrator at the center, sovereign boundaries locked, and FinOps routing working in real time. This active system is a sharp departure from the passive textbook models used only a few years ago. Recruiters are now specifically looking for engineers who understand hybrid configurations, FinOps, and sovereign deployments. Presenting a portfolio limited to basic web hosting is no longer sufficient for technical interviews at this level. Your work must demonstrate an understanding of intelligent, constraint-aware systems. It is time to look past the homogeneous cloud strategies of 2020. The industry has transitioned from global passive hosting to a model of sovereign, intelligent fragmentation. The terminal here shows a local LLM deployment. Learning the mechanics of this script is the next step in upgrading your skill set. If you want a technical deep dive into this deployment process, let me know in the comments. Adapting to these architectural shifts is the core requirement for engineers working in this new environment.